Types of modulation. Amplitude modulation, AM, a frequency modulation, FM, a phase modulation, PM, amplitude and phase shift current, APS quadrature amplitude modulation, QAM. Amplitude modulation. When an amplitude-modulated signal is created, the amplitude of the signal is varied in line with the variations in intensity of the sound wave. In this way, the overall amplitude or envelope of the carrier is modulated to carry the audio signal. Here, the envelope of the carrier can be seen to change in line with the modulating signal. It is the process in which the amplitude of the carrier signal is varied in accordance with the information or modulating signal. Frequency modulation. It is the process in which the frequency of the carrier signal is varied by the modulating signal while the amplitude remains constant. Phase modulation. It is a digital form of modulation where it switches between different phases, 0, 1 binary. Is used for radio communications, mobile communications, and even maritime radio communications, Wi-Fi, satellite, etc. A carrier signal plus digital audio signal equals modulated signal. Frequency spectrum table and computations, NCA. Frequency spectrum. Session 4. Title: Public Address Systems. Architecture for Public Address System. Public Address System. Microphone. A microphone, colloquially nicknamed mic, is an acoustic-to-electric transducer or sensor that converts sound into an electrical signal. Electromagnetic transducers facilitate the conversion of acoustic signals into electrical signals. Microphones typically need to be connected to a preamplifier before the signal can be amplified with an audio power amplifier and a speaker or recorded. The sensitive transducer element of a microphone is called its element or capsule. Except in thermophone-based microphones, sound is first converted to mechanical motion by means of a diaphragm, the motion of which is then converted to an electrical signal. A wireless microphone contains a radio transmitter. Amplifier. The classification of an amplifier depends upon the size of the signal, large or small, its physical configuration, and how it processes the input signal, that is, the relationship between input signal and current flowing in the load. Amplifiers can be thought of as a simple box or block containing the amplifying device, such as a transistor, field effect transistor, or op-amp, which has 2 input terminals and 2 output terminals, ground being common, with the output signal being much greater than that of the input signal as it has been amplified. Generally, an ideal signal amplifier has 3 main properties: input resistance, or RIN, output resistance, or ROUT, and of course amplification, known commonly as gain, or A. No matter how complicated an amplifier circuit is, a general amplifier model can still be used to show the relationship of these 3 properties. The difference between the input and output signals is known as the gain of the amplifier and is basically a measure of how much an amplifier amplifies the input signal. Loudspeaker. A loudspeaker, or speaker, is a device containing 1 or more electroacoustic transducers, which convert an electrical audio signal into a corresponding sound in order to translate an electrical signal into an audible sound. Speakers contain an electromagnet, a metal coil which creates a magnetic field when an electric current flows through it. This coil behaves much like a normal, permanent magnet, with one particularly handy property. Reversing the direction of the current in the coil flips the poles of the magnet. Inside a speaker, an electromagnet is placed in front of a permanent magnet. The permanent magnet is fixed firmly into position, whereas the electromagnet is mobile. As pulses of electricity pass through the coil of the electromagnet, the direction of its magnetic field is rapidly changed. This means that it is in turn attracted to and repelled from the permanent magnet, vibrating back and forth. The electromagnet is attached to a cone made of a flexible material such as paper or plastic, which amplifies these vibrations, pumping sound waves into the surrounding air and towards your ears. What is Ohm's law? The law states that electric current is proportional to voltage and inversely proportional to resistance. A voltage is the amount of potential energy between 2 points on a circuit, or one point has more charge than another. This difference in charge between the 2 points is called voltage, the amount of charge flowing through the circuit over a period of time. Current is measured in amperes, usually just referred to as amps. An ampere is defined as 6.241 by 1018 electrons, 1 coulomb, per second passing through a point in a circuit. Amps are represented in equations by the letter I. A resistance is the degree to which a substance or device opposes the passage of an electric current causing energy dissipation. V equals I dot R. V equals voltage. I equals current. A. R equals resistance. As the electrons move through an object, they tend to collide with atoms and other electrons. The energy from these collisions is given off in the form of heat, and the amount of heat generated depends on the resistance of the material the current is flowing through. A resistance is measured in ohms and tells us how much the material blocks the movement of the electrons. When designing an electrical circuit, devices which have a high resistance can be placed in the path of moving electrons in order to reduce the electron flow, current. These devices are simply called resistors. We can see that when voltage increases, the amount of current also increases, and when a resistance increases, the amount of current decreases. These ideas are expressed by Ohm's law. V equals IR, or R equals. Series circuits have all of the devices arranged so that the electrons must travel through each device.